Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. Please like, share, and subscribe. In this video, I will be calculating the values for a resistive, inductive, parallel complex circuit from the Chapter 16 math handout, problem number 29. So we're looking here at the way that we need to set our notebook up. All of these electrical quantities are the same as our other complex circuits, except when we were doing series, we were using theta Z, and now that we're doing parallel, we want to use theta 1. So you may want to pause the video, write out your spreadsheet here. You'll have to have this spreadsheet memorized to do your calculations on the test. I'm not going to provide you with any paper with this written on it. You'll have to write it on your scratch paper from memory. I also highly encourage you, as you're setting up your notebook, leave space to write the steps that we take to solve the circuit, because you need to work and rework these circuits several times, and if you get stuck anywhere along the way, you can look at the steps and see what the next step should be. And this is the way we would set our notebook up for problems 25 through 32. So let me go to problem 29. So here we see problem 29, and I've got certain values already filled in. I am taking those values from the Chapter 16 math handout that you see here. I'm taking my 50 volts, my XL of 50 ohms, and my resistance of 50 ohms. XL stands for inductive reactance. I'm going to use this frequency here with problems 25 through 32, and we definitely do need to know the frequency in order to do our calculations. So as we look at the spreadsheet here, you see that I have filled in my known values of 50 volts, 50 ohms for inductive reactance, and 50 ohms of resistance. I got the steps covered up right now. That way, if you want to go to this page in YouTube and pause the video, the steps will be covered up. Then you can fast forward the video a little bit and see the steps if you need to. I have the formulas here, formulas 21 through 24. I have clipped them out from the Chapter 16 formula sheet that you see here. And whenever we're doing a parallel circuit, I want to remind you, you can only use formulas 21 through 24. Now, if you needed to use the XL formula, which that doesn't look right, it got messed up. Let me fix that. You may need to use formula 14. 2 pi is, XL is equal to 2 pi FL. But my main point here is, when you're doing a parallel circuit, do not use formulas 17, 18, 19, and 20. And I'm going to show you here in a minute, as we're doing the calculations for this circuit, how easy it is to use one of these formulas over here whenever you're solving your parallel circuit. So 17 through 20 is only for series complex. 21 through 24 is only for parallel complex. Make sure you remember that. Very important. All right, so I see here that I have a parallel circuit. So the first thing that I realize about a parallel circuit is that voltage stays the same. So I can go ahead and fill in my voltages. And now that I have 50 volts for VR and I have an R of 50 ohms, I can go ahead and find IR, because I have 2 of the 3 here. So I'm going to go ahead and solve for IR. I'm going to put in 50 volts over 50 ohms, and yep, you guessed it, 1 amp. Again, My next one I'm going to find is IL, and it looks like, again, we have 50 volts and 50 ohms, so that looks like that'll be 1 amp. The next thing we're going to solve for is IT. But before we solve for IT, I want to take a moment to point something out to you. Here you have XL and you have R. So the temptation is going to be to go ahead and find ZT. But I want to point out to you that you cannot use formula number 19 to find ZT. You cannot use formula 19 to find ZT. If you do, you are going to get the wrong value. Let's look at our spreadsheet again, our formula sheet again. If we look here, we see that when we want to find ZT in a series circuit, we're going to use that square root formula. But when we're in a parallel circuit, we cannot use number 19 because you cannot cross this line right here. You can't cross this line. You have to stay over here and use formulas 21 through 24. So the temptation may be to go ahead and find ZT, but you cannot use formula 19 to do that. What you have to do to find ZT is you have to find IT first. So let's go ahead and find IT. And if we look at formula number 22, it shows us how to find IT. So let's look at the calculator. We're going to first open square root. Then we're going to punch in IR of 1 amp. We're going to square that with that blue button that's highlighted right now. That's the squared button. So we put in, look at the formula here to double check. We put in IR and we squared it. We're going to put plus. Then we're going to put IL and square it. So 1 squared, it equals. So our total current in this circuit is going to be 1.41 amps. All right. Now that we have IT and we have VT, that is how we're going to go about finding our ZT. And I want you to write this down and remember what I'm about to say to you. Z stands for impedance. Look closely right here. You'll see that Z stands for impedance. XL stands for inductive reactance. And R stands for resistance. They are all types of opposition to current flow, and they are all measured in ohms. They're all types of opposition to current flow, and they're all measured in ohms. So we've got impedance, inductive reactance, and resistance. And I may ask you what the Z stands for on the test, because I want you to know it stands for impedance. So let's go ahead and calculate our impedance. We're going to use a fancy version of Ohm's law. That's all this is. ZT is equal to VA over IT. Reminding you again that VA and VT are used interchangeably. So ZT is going to equal the 50 volts over 1.41 amps. And that's going to equal 35.46 ohms. And what impedance is, it is the combination of both reactance and resistance in a circuit. All right, so we completed step 5. That leaves only one step left for us, and that is theta 1. So on our calculator, we're going to hit shift then hit tangent right here. We're doing inverse tangent. So it's shift, then tangent. And we must look very closely at the formula because you see right here there is a negative sign. That negative sign is required on your answers on the test. You have to put negative whatever the answer is numerically. You don't have to put the degree symbol, but you do have to put the negative sign before the number. All right, so it's minus IL right here, IL, 1, hit over under IR of 1. We're going to hit the scroll over button. We're going to close the parentheses. We're going to hit equals, and that is negative 45 degrees. As I said, it is a measurement of degrees, negative 45 degrees. All right, now that we have found all of our values down here in our spreadsheet, we're ready to provide whatever's asked for on the homework, IT, ZT, and theta 1. That's what I asked you for on the Chapter 16 Math Handout Canvas Answer Sheet assignment on your Canvas page in the Chapter 16 module. As I've said before many times, I recommend doing all of these problems on paper first. Once you have that completed, open the assignment on Canvas and punch in all of the numbers that you've already calculated. Because if you leave Canvas open while you're doing all of these math problems, anything could happen, power could go out or anything, and you lose all that work that you've been working on. So it's better to do it on paper first. I hope this helps you. If it does, please leave a nice comment. Let me know if there's something I could have done a little better. You can let me know that too. Just be gentle. Don't tear my head off. But just let me know if there's a little something I missed. And like I say, please like, share, and subscribe. Hey, maybe you could share this on Twitter. Share it on Facebook. Whatever. All right, I hope that helps you. Thank you very much.